All right, part 2 of our Unit 2 review here, finishing up on the back, talking a little bit here first about the quadratic formula. Now, we've got a story problem here, but it still is going to use the quadratic because we're given a model, we're given an equation that's not factorable. So we need to figure out the height measured in feet and x is measured in seconds. Use the quadratic formula to identify when the ball hits the ground. So the quadratic formula, little bit of a chunker of a formula to deal with, but my A value, and my B value, and my C value, and we just plug those in. This is the part that people normally forget about. They forget about the opposite of B part. Not sure why that is, but not something we're getting caught by. Again, we've talked about this before in class 2. When I'm doing this part, I'm not going to use the square root because the calculator naturally puts a parenthesis in here, and that usually causes people problems in getting wrong answers. So what I normally will suggest is that we just look at it this way. And then at this point, we're working with a story problem. Normally we'd look to break down the radical, but I mean, we don't talk in radical speak. Hello, it took me -18 plus or minus square root of 388 seconds. No, we don't do that. So we're going to go ahead and we're going to do like -18 plus the square root of 388 and then divide that by -32. So you're like, okay, so -0.05, and then let's do our other one, -18 minus square root of 388 divided by -32. Are both of my solutions appropriate? Well, I would have to say no. When the ball hits the ground, we're talking about time here. So negative time doesn't make sense. Well, except unless, let's say, you're in a Back to the Future movie, but otherwise, I really don't think that's going to do much for us, okay? Now for this next one, I sort of like to think about this next one graphically. So in a minute here, I'm going to put 3 pictures up. We're going to kind of play a matching game to see how this works. Describe a quadratic function that has. Okay, so let's say we have these 3 pictures because they represent the 3 parts that we have here. One real solution means my graph only crosses the x-axis in one place. So 1 x-intercept. That's all I need to describe it. How many x-intercepts would I have for one real solution? I'd have 1. That one right there. 2 real solutions. I would have 2 x-intercepts. And then the weird one, 2 imaginary solutions. How many x-intercepts does this graph have? 0 x-intercepts. And that's all I'm looking for there, okay? But you've got to have the intercepts in there. We've got to just make that connection between solutions and intercepts. And then finally, down here on the bottom, okay, graphing the following. F of x, remember, is just a fancy way of saying y. These are the 2 problems that I'm going to be doing my shading on. So as always, I got to have my vertex. You're like, wait a minute though, there is no x value. Well, we're going to use 0 then. So my A would be -1, my B would be 0. You're like, well, if your B is 0, that's going to make your x value your vertex 0. I agree. My y value is just plugging that 0 back in. 0 squared is 0 plus 4 is 4. So my vertex is at 0, 4. It's opening downward. So if we're going to do the pattern, we go down 1 and right 1, down 1 and left 1, down 3 and 1. And again, I can go plug this in my calculator and use the chart too if I want to. 1, 2, 3, 4, 5. But now here are other little things to watch for. It's not or equal to. So if it's not or equal to, I'm going to use a dotted boundary. And then when I go to use a test point, again, any test point inside the parabola is going to help me figure out where to shade. Well, I love using 0, 0 when I can because it's easy to substitute in. And it happens to be inside my parabola. So again, plug in 0 for y, or my f of x. Plug in 0 for x. And then answer if that statement's true or false. Is 0 less than 4? That's true. So we shade inside the parabola. And that would be how it would work on either of these. Here, I do have an a and a b this time. Negative b over 2 times a. So then my y value, I would just plug on in. Get 4 minus 8 minus 3 would be negative 7. So my vertex is at negative 2, negative 7. And again, once you practice, this is the type of pacing you should be able to do on this. It shouldn't be stare at the problem for 2 minutes trying to figure out what negative b over 2a is. If you've practiced, it's going to show. If you haven't, it's going to show. My a value is 1, so again, I can use the chart on the calculator, or I can just follow my pattern, which again is up 1 over 1, up 3 over 1, up 5. Oops, I didn't do my over 1. Get that drawn in. Again, I want to use a point that's somewhere towards the middle. I don't want to pick the point that's right near the edge here. So I'm going to happen to use negative 2, 0. So my y value is 0. It's greater than or equal to negative 2 squared is 4. 4 times negative 2 is negative 8. Minus 3. So is 0 greater than or equal to negative 7? Last I checked, that would be true. So again, I'd be shading on the inside. If it was false, I'd be shading outside. So then our last two, solve and write your answer in interval notation. No shading needed here. We need x intercepts. In other words, where y equals 0. I'm going to show you a trick here on the second one. First thing, all my terms have to be on one side. So I'll minus the 56 over. Then I need to factor what's there to find my zeros. More than likely. So I factor this out, set those equal to 0 to find my intercepts. So I'm going to make myself a quick sketch of what this looks like. I'm not going to go ahead and find the vertex. You're like, why are you not going to find the vertex? We're graphing a parabola. You always find the vertex. Because the intercepts are the values that I need. The vertex isn't going to directly affect this. So I know it's opening up because of the x squared. So I'm just going to go ahead and sketch what this looks like. Because here's the part I need. Less than 0. Where are my values? My y values, because that's in the same slot the y was before, less than 0. Well, that would be below the x-axis. So I'm looking at these values to try and get that done. And if I'm doing interval notation in there, interval notation works from left to right. So I'd start here at negative 8 and keep going and going and going until it stops here at 7. And I'm done. So if it's below the x-axis, it's going to be a pretty short interval notation. You're like, okay, so what if I'm either not good at factoring, or how do I kind of figure some of these other things out? Well, this other one, since it's greater than 0, would be above. Now we'll get to the graph in a minute. I want to show you something you can do on the calculator if factoring is truly a struggle for you. What I would do is I would type my expression into the calculator and I'd pull up the chart. And you're like, okay, so what good does the chart do me? Well, what's going to happen, let me make sure I typed everything in right here. Okay. Is I'm going to start floating through my chart until I see some values that get to 0. If I see a 0 in the y equals, that tells me where my x-intercepts are. So like 9, see, y equals 0, and -5. I could also get that by factoring. So you're like, okay, so if I have those, again, it opens up, so I'm not really worried about what's going on down here. But now, since it's greater than 0, I want the values that are above the axis. And that's going to change my interval notation significantly. Because now, this goes forever, never, 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 never to the left. So I start at -infinity. Until it comes down and stops right here at my first x-intercept. Again, bracket because of the or equal to. And then nothing, 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 nothing. Oops, starts again. Where? 9. Goes where? Forever to the right, to infinity. So again, these are the type of things we're going to be looking at tomorrow. When you walk in, tests will be on the desks and have you ready and raring to go. So I hope you are ready, and we will see you then.